Hi, everyone. Today we're going to be doing week 4-2, and Sebastian will be leading today's lecture again, and myself and the other TAs will be in the chat answering questions. Does anyone from my TA side of things, Min or any of the TAs or Jesse, have anything to add really quick before we get started?
Nothing to add, thanks.
Okay, so
Yeah, whenever you're ready, Sebastian, thanks.
Yeah, it looks like most people are here, so I'm going to start now. Okay. So hello again, everyone. I'm Sebastian Meldina from New Jersey Department of Environmental Protection, Bureau of Air Monitoring, and we're just going to be doing the second half of the week 4 material. So actually, before we start, just letting you know, there's no libraries to load for this session. So don't. One thing to note that I'm not sure I see when we're having other participants share the screen is that they tend to have environment variables from other sessions. So one thing I would recommend every time we have one of these classes is to go into session and then click restart R. I already done this. And then once you've done that, to click on the little broomstick icons in your environment, and then this one in your console, so that we make sure we have a fresh session and we don't have variables from other weeks, because a lot of them share similar variable names. So just make sure to do that. I would recommend that as we start every class. So our first, and we're on week 4-2, just as a reminder. So our first, this week is actually not too bad. Our first material we're going to cover is subsetting vectors. So we've worked with vectors before in this training, which are generally those lists where they're basically one list of variables. So to create one is very easy. So you just set a variable name, and then we use the concatenate function, C, and then you list a set of variables. So for the first block of code, we're just setting a few numeric values. So just follow along, 1, 3, 5. And between each variable, you separate with a comma. And then obviously you have close parentheses. So then you can see, and then we can obviously do like print A, and you'll see that it'll have a vector value, which is the first row, and then each of the values. So to subset, if you want a specific, obviously just printing A just prints the whole vector. To subset ones, we use brackets. So for the first example, we're going to get the first value, and the first value always starts at 1. So here we're just going to get 1. So we're subsetting the vector to the first value, and the first value is 1. And then just another example, a value later on in the vector, so 3, so it's going to be 5. And if you wanted to have a list of values, let's say you wanted one specifically at a certain index, you would do the same thing. You have your variable name, and then brackets, and then in the brackets you would do a concatenate function, with parentheses, and then you specify the index values. So in this case, we're going to get the first and the fifth value. And then when we run this, we should expect the first value, which is 1, and then the fifth index value, which is 9. So it prints that out. And then, okay, Min shows an example of, so obviously this vector has an index between 1 and 6. But let's say you chose an index value that is out of bounds or just not present in this variable. So in this case, 7, but there is no 7th value. And it looks at the variable and it sees that there isn't a 7th value, so it'll just return NA. So that is expected. That is not an error in this case. So I'll just write the notes for this one. Expect NA. Expect 1. Five. So I'm just writing down the expected values for this function. And you can also remove values for a vector using a negative value for the index. So in this case, we're getting rid of followed by the index number. So in this case, we're getting rid of the 3rd value. And if we run it, you see that we remove the 3rd value, which was 5, 3rd index value, which was 5, and we return 1391. Now, if we print A again, you'll see that that isn't saved. That is only affecting the output. So the way to save that is to set it to the function name again. And as you can see, if we print it again, you'll see that 5 being removed is saved and the index number changes. So this is typically a quick base R way to modify vectors, and sometimes this is useful to do this manually if you're interested in testing something. So I'll just add some notes for people to see. Negative value to value and saves. Okay. So yes, that's just the first section, pretty straightforward. For the second section, obviously vectors is, oh, well, actually there's a second part to this first section. So if we have, obviously this vector is very short, but maybe you might have a very long one and you want to know something specific. So that's when the which function comes in. And so this is to find the index of specific values, and it checks whether or not it's true or false. So in this case, we're going to use the which function, and we're going to see when A is equal to 9. And if we run that, it tells us that the index value is going to be 4. Now, actually, that, if I rerun the original line again, because I did remove it, it's going to make 5. So I would recommend, because I was just showing an extra thing, that we rerun line 3 down here so that we just follow along with what it's in the material. So yeah, so in this example, at index number not 5, 9 is present. So that's just a simple, quick way to check. You can also use other operators, not just equals. So A is, let's say, if we're looking for when the value is greater than a number, so 5 in this case, it'll give us the index values for the numbers that are greater than 5. Obviously, it's greater than 5, not greater than equals to 5. So in this case, it's index 5, 4, 5, 6, or 7, 9, 11. So let's just write this again, just for note taking. And then you can also use the inclusive operator as well. when A, in this case, this is similar to what we were doing before. And that's going to be when, if you want to test multiple variables, you use the in function, and then it shows that an index 1 and 3 is 1 and 5. So 1 and 3. So that's just some simple base R stuff that you can do with vectors. So we're going to go to the second section now. Now, typically, obviously in R, we use a lot of tables and stuff. So we typically work with data frames. And so this next section shows how to subset a data frame. And it's very similar. Actually, I'll pull up the visualization they show in the notes. So obviously we have our data frame with our rows and our columns. So it's always done row first, column second, similar to Excel. So in this case, we separate in the brackets with 1 to 3 and with for subsetting the rows, and then 1-4 for subsetting the columns. So we'll go back to our studio. So in this case, we're going to be using the base air quality data frame from R. And this is just to look at it again. You have the column names and the various values. So here we're selecting row 1, column 2. Using air quality, so we name the variable first. And then we're going to select row 1 and the second column, and it's going to print out the values. So pay attention to the values from here. So if we look here in row 1, column 2 for solar.r, it's going to be 190, and that's what we get printed out. So expect 190. And then this is just another example, subsetting multiple rows. And then we're going to do, and then a colon 2, so subsetting rows 1 to 2. Selecting sign 1 to 2. And we have to, even though we're not specifying a column, if we want to specify all the columns, you still have to put a comma and then just leave it blank in this case. So obviously it shows us the column names in the first 2 rows and all the values in there. So first rows. And then the final, if we just wanted to see all the values in a specific column, and obviously we put brackets. And then again, if you want all the rows, you don't just skip entering the value, you put an empty space and then separate by the comma, and then you do for a column, we're going to do the 4th column. And of course, it just doesn't actually show the column like straight. It'll just show all the values like this. So, it's not the best way to view it, but this is just generally how R looks at it. But if we scroll, it looks a lot like the temperature column. So all values. Okay, so that's just subsetting row vectors and data frames. It's pretty easy. Is there any obvious questions, Jess, I need to go over, or am I free to keep going?
Nope, you can keep going.
Okay, great, thanks. Okay, so now we get into the meat of this section, which is for loops. So I am going to bring out the visualization again, so that we can understand it. So far we've been doing a lot of things manually where we specify the length and the range of values that we want to be changed or viewed and things like that. But in many cases, especially a lot of real life examples, you're not necessarily sure exactly how long any specific data is. You can maybe have tons of different data sources, and it would be tedious to have to constantly come back in the code for every separate data source and change the lengths of your code so that it would be in line with your data. So, but luckily there are ways for you to write code that allows R to look at what the length of data and then perform a task. And that's where we use loops. So I'll take a break from the code to show a visualization. So there's typically, in most code environments, there's typically 3 loop types. But for this section and generally in R, we only focus on 4 loops, but I just showed this image just for knowledge. So generally speaking, we're focusing on 4 loops. Basically, you initialize the loop and you have some code that you want R to perform on specifically, so like modifying the data, calculating something, things like that. And then once it reaches the end of the data that you're inputting, once it finished completing the task that you want, it'll check to see if there's more data to work on. And if there isn't, it goes back and restarts and performs the same task again, and it keeps going in a loop, which is where the loop aspect comes from, until it reaches the end, and then it will stop and it'll continue your code. So we're going to be focusing on beginning of section 3 here. And so yeah, we're focusing on this, and I provided another example here to go over, and I'll be typing it out, don't worry, I'm just showing this for. So in this example that we have in the notes, we're trying to calculate the medium of the data. And so we're going to basically follow along like this and perform this task. And then once it finishes calculating the medium of each of the columns, it'll end and print out the values. So first, we're just going to do a very basic loop example to showcase this. And then we'll move on to actually doing the real example. So in this example, we're just trying to print out a list of values based on just like a set of rows, basically. So generally, when you're doing a for loop, we start by using the word for, and you'll see it changes the color. And similar to the if-else statements, first we have parentheses to define the test statement. In this case, we use the I value, and I is a placeholder value similar to like X and things like that, that just says basically I is whatever length of the data that we're going to be working on. So we don't need to specify the length of the data. And in this case, we're just going to be doing for I in the length of 1 through 6. And then after we're done writing our test statement, we put brackets, and then we specify this is our what we want R to do on this data. In this case, we're just printing out the value. So we're doing the print whatever value is for that length. And so R is just going to iterate through this. And as you can see, it's just going in and saying, okay, value 1, we're going to print whatever value that is. It's just going to be 1. And then for value 2, we're just going to print the value 2, value 3, so on and so forth until it reaches the end of first, which is, in this case, we're specifying. Just go through this 1 to 6 times. And so once it reaches 6 times, it knows to stop, and then it keeps going. So it just printed the values. That's a very, very basic example. So I'll just add a little note. Prints the value of 1 through 6. And so then another way we can specify how long this loop should go is to add the length of a specific statement. So in this case, we're going to be reusing the A vector that we're using. So in this case, A could be any length that it could, n number of lengths, but in this case, it's going to be 6, but we don't need to specify the length of A. And again, just for a reminder, we're just going to print A here so we can see it. So it's a vector of 1 through 6 and has these values. So for these values in A, so we're going to start our for loop again, and then we're going to say whatever length of in, and then we're specifying the range it should be. So start at 1, and then whatever the length of A is. And then, of course, that's our range that we're choosing, and then what we want the loop to do. So in this case, we just want to print the values.
Yeah, I'll just add it
of A in semicolon of I. So whatever length, print the value of A subsetting whatever value the length is. So, and then we're going to run this loop. And so as you can see, it goes through it calculates the length of A, and then it runs each index value and prints out whatever that value is. So it goes index value 1 is 1, index value 2 is 3, 5, so on and so forth, until it reaches the end of A, and then it stops and it gives us the values. And then let's see. And I see that I think this is a similar way to do this, I believe. So you can do you can do sequence along another way, which is easier because you don't really necessarily need to write out this in a semicolon way. You can just use the in to do it. So basically you do for I, and then you sequence along, which just calculates this for you. So you can do A, and then of course we use our brackets, and then we're going to print the value of the index at whatever length that A is, and oh, okay, I included too many ins, sorry. Okay. And so as you can see, this is exactly the same output as the first one. It's just, instead of manually inputting this calculates this for us. So I'll just add the notes that were in the thing, which is and then another way to use is just to do it like this. And as you can see, so there's these three from 47 to 57 all provide the same output. They're just different ways to write it. And so now we're showing how to kind of calculate something. Here so far we've just been printing values. So in this case, we're going to create a new variable, sum A, and set it to 0. We're going to create another for loop. So again, the statement is inside. So for I and A, so whatever values are, whatever length A is, we calculate the sum of A based on and on adding, we calculate sum of A based on the values that are in the vector. So in this case, we're adding all these values together, but again, we're not specifying the length. So R will just look and calculate this. And once it sees that there's no more values, it'll add it together and provide the sum. So this is, oh wait, whoops, sorry. So then, as you can see, and if we print summing, you can see that this just adds it up to a total number, which is 36. So for loops are also useful in calculating values very quickly. So I'm just, for the next little section, just going to copy a little bit to save a little time, because this is like the kind of repetitive. So in this case, we're creating a data frame of random values. Oh, whoops, sorry. And you can click up to see what those values are. And in this case, maybe one way you would approach it would be to calculate median. You wanted to know the median value of all these columns. And so you might think, well, okay, I'll just input do the median function for each of these values. So I'm just going to copy this 4 times. And actually in the notes, it's actually putting all this in column, but this is really how you would do it. You would, and just run the code. But of course, even though this shows us data, this isn't a very efficient way to do it. And it's not even easily visually to compare these values. Here we only have 4 columns, but what if we had like the whole alphabet or something? Then this becomes messy and difficult to look at. So this is when we're going to be doing the example that I showed before. So we're going to use a for loop to calculate the length of this data frame, calculate the median values for each of the columns in this data frame instead of doing the method I was showing, and then print out the values all in one line, which is much easier to read. So to start, we need to know the length. We would like to create a vector of with the length of the columns in this data frame that we generated. So we're actually going to create a new variable, median df, and we want it to be numeric because it's going to contain numeric values that we're going to calculate. And then we use ncol, which is the number of generates the number of columns in this data frame. So in this case, it's df, what we generated up here. And so as you can see, all it does is just creates a data frame, but we didn't specify any values, so it just sets it to the default value, which is 0. And so this is just like a blank vector that we're creating so that we can run it through our for loop to calculate the medians for each of them. So we're going to start with our for loop. So we're going to do for, and then we want a test sequence. So in this case, we would like to calculate the median of each of the columns but we don't want to specify what columns. It doesn't really matter for a for loop. So we use, again, I as the independent variable. And then we're going to use sequence along. And then it's going to be df. And then for our statement that we're going to be putting, we're going to do medium df. And we want to append our empty median df vector with the median values. And then we're going to calculate the median by using the function median. And this is in base R, by the way. And then we're also going to subset the vector because we don't want to calculate the median of all the rows and columns and of all the rows. We just want the columns. So we're going to subset this vector to calculate it properly. And we don't want any of the rows, so we're going to skip it by just we can just do it like this, putting an empty blank space and putting a comma, and then we're going to use the independent variable I. So that's just going to see the length of the columns in df. We're going to calculate the median, and then we're going to save that to our vector. I'm just going to write that. Calculates median of f and saves it. And then we just want to call median df again so we can see it. So I'm going to run it from here just to be safe. And as you can see, these change. And when we print it out, we get the medians of each of the columns. And let's say we were curious, we wanted to check that this for loop work. So one way you can do it, I believe in summary, does tell you the medians, if I remember properly. Yes. So here's a good way. If you were, say, you were calculating a specific value in a for loop, you can use this of a specific data frame. You can use this summary function to check your work. So we can see here that this did work successfully. We're looking at the median value for summary. As you can see, they match generally with the values that we generated in the for loop. So that was a lot. I'm wondering if there's any major questions. Jess, there might be.
So far, there actually isn't in the chat. How's everyone doing?
I'm
For
very
loops
surprised.
is like, you're right. For loops is like
Yeah.
my
Does
Roman Empire.
anyone a more general explanation? I know it can be a little confusing. Maybe even you, Jess, because I know you might not.
Yeah, no, this visual is like perfect.
So I'll just explain a little bit, elaborate a little bit more. So the best way I visualize this for loop is an assembly line. So basically, in this case, the input is going to be the data frame. And as like an assembly line, you don't have everything being worked on at once. It breaks it, an assembly line breaks up tasks in smaller pieces. And so in this case, each R is separating each of the columns and performing something, which is what you put in your code body, in this case, calculating the median, and then provides an output. And then once there's no more things to work on the assembly line, it's finished and it stops. And then you get out the product. So in this case, we're trying to process by calculating the data frame and calculating the median, and then printing that out into a vector so that we can see all the values. So that's the best way I visualize this. And of course, if you think of an assembly line, it's always constantly moving. It doesn't stop until there's no more things to work on. So that's generally why we write this, because we don't then need to keep telling R to work on its task. It just keeps working automatically. So that's the best way I visualize of loops, and specifically a for loop. Let me see if there's like any other not sure if there's any simple questions, any kind of things. I see we have a little time, so I might as well, because it's only one exercise, I might as well go over the exercise. If there isn't any major questions, because it's just another example, so it might be good.
Yeah, I think that's a good idea. 'Cause
Okay,
there's
so
still
I
no
wrote-
questions.
Okay, wow. I mean, I don't know if that's good. I'm guessing that's good. So I wrote it in this format, so I'm just going to basically go over it a little bit. So in this case, and I'll show what the question is so we can see it. In this case, the exercise is write a loop to compute the mean of first 4 columns in air quality data. Now I actually just went ahead and just did the whole vector, I believe. I mean the whole data frame. But basically, we save the value of air quality to be just so that we can easily manipulate it and see it in our environment. And then we first obviously want to do similar like before. We want to create a blank vector so that we can input the mean later on in our for loop. So we just do the same thing. We create a sorry, because there's going to be other. We're going to create a blank vector with just zeros based on the length of the data frame. And then we do the similar thing where we on the sequence along to air quality new. I'm just showing like doing the whole thing, and I can probably adjust it to show specifically the length similar to what we did before. And we calculate and I'm actually going to showcase something here. We calculate the mean, so we switch this from median to mean based only on the columns, and we save it to the vector's length for I. And then when we do this, I'm actually just going to run the whole thing. You're going to see that, it's going to be the result, that there's some NAs. And this happens sometimes with some functions when you don't specify to ignore NA. So obviously, if you're calculating NA is a null value, is not a numeric value, and so it can't calculate the mean or the total average of the column, and so it spits out NA. And you can use summary function to check if a column has NAs. So to fix this, what we normally do, some functions allow you to specify, and if I do question mark mean, you can see that we have various arguments for this function, and one of them is in na.rm, which is if we a logical argument that specifies if we want to ignore NAs. So I added to remove the NAs for this for those columns when they're calculating the mean. And when we run this again, you can see even though we have NAs for these columns, we're still able to calculate the mean. So this is just for the whole length of the column. I believe the other way you would do to do the other row to just have a specific length is you would do for I in, and I'll just copy this, and you would do let's see. Okay, I in, and then you would do I think he would do, I'm not sure actually. I think he would just do for I in 1 through 4, I believe. I forgot exactly. Or you would just subset the see if that worked. Yeah. So you can see here, it only calculates the first 4 data frames, and it only having these zeros because I calculated the number of columns between for the entire row, but I would just do, I believe I would just do 1 through 4 like this. I'm just kind of going on a whim here. I believe that would, yeah, that would just shrunk and only show you the first 4 columns. So that's just another way you can use subsetting. If you were just looking to get a specific result, like you were only interested in this case in the first 4 columns, you can use subsetting to minimize the amount of values calculated. So that's a way to specify your sequence. If you want it for a for loop, if you want it to be do it in say batches or something like that, you can do I in and then the subsetting using columns. I mean using colons for the length of the sequence. Just if you want a specific sequence, but generally it's used to do a unknown length of a specific data frame. So that's it for this week. Is there any other major questions? And not, I guess we can maybe end early. I'm surprised this actually went that fast.
I know, me too, but honestly, I feel like I understand for loops now.
Oh, wow.
I know, right?
I'm very surprised. That's really good. I'm not sure other participants are at the same level. I'll just stop sharing just so I can see.
Yeah. I mean, yeah, feel free to take a peek in the chat, but it's been pretty quiet today.
Okay.
Yeah, so unless anyone has any other
Let's
questions
see.
for the remaining like 15 minutes, or yeah, then maybe we can end it a little early.
Yeah, I see the question about the PowerPoint. I think the one I already uploaded has the same material. The one that I provided for week 1, you can just copy that just into week 2. I mean,
Okay.
The day 2, because it's the same thing. Where we can find the extra code.
Oh, the thing you just went over.
I'll send this week's material. I mean, code. But yeah. But the PowerPoint is the same.
Yeah, I'll move the PowerPoint. Yeah, we can I can share, honestly, my code has a solution for the exercise, so I can just share mine on the.
Yeah.
So
If you.
Yeah, no problem. I'll do that.
Yeah.
I
mean, I mostly just copied what's written in Min's.
Yeah.
As many notes as other people, but.
Yeah, if you were trying to follow along for the exercise, you're kind of doing the same thing you're doing for the previous one, just instead of making the blank vector the length of the air quality vector, you only need to make it a length of 4 because you're only looking for the first 4 values. But even if you did it like, with the whole vector, it's still fine. You'll just get 6 answers or something instead of 4. But
yeah,
you could really just do it like we did the last example.
Yeah.
But I'll still post my code anyway, just so everyone
that's
has
fine.
it, because I took a lot of notes.
There's as with many code things, there's many ways to get the same results. So
Exactly.
sometimes it's more efficient, but you can still do it different ways too. It's still fine.
Yeah. All right. Well, if there's no other questions, we can let you guys go. Thanks for joining.
Thank you.
Thank you.
Thank you.